This is going to be the Unit 7 review video for 7th grade. I'm going to do day 1, day 2, and day 3 in the same video. So number 1, Jimmy wants to serve iced tea at his birthday party. He purchases 21 containers filled with 1.5 liters of tea. Approximately how many gallons of tea did he purchase? And it tells us that 1.5 gallons is about 3.8 liters. Anytime you're not sure what to do with things like this, make sure you highlight information that looks important. Usually numbers are a good place to start. So we're talking about 21 containers here, and it tells us he's got 1.5 liters of tea. And then we've got pretty much a flat out ratio right here. Now what I want to say is this has little to do with the unit that we've been on, but this is a review question, and that this is something that we've got to be good at. Anytime they give us just a flat out ratio like this, you've got to know that it's going to be a WKU of some kind, where we have words, known, and our unknown. Pretty much line equals line equals line. Because of that part I've got highlighted in yellow, we're going to compare gallons and liters. And it tells us that 1 gallon is approximately 3.8 liters. And we need to convert that 3.8 liters, I'm sorry, not the 3.8 liters, but we need to convert that 1.5 liters into gallons. And because it tells us that he's got 21 containers filled with that 1.5 liters of tea. And we're going to assume that's each. I'm not really happy with the way this is phrased, but we are going to assume 1.5 liters is in each of those containers. So right here, we are going to convert that 1.5 liters that's in blue, and we are going to convert that to gallons. So this is an old case of cross multiply, divide by the lonely guy. So you cross multiply these two. 1.5 times 1 is still 1.5. And now we divide by our lonely guy. So we're going to be doing 1.5 divided by 3.8. And 1.5 divided by 3.8 is some crazy long decimal. So I'm going to round it considerably. It comes out to 0.39 and a whole lot of other numbers. So we're going to call it 0.4, or about 0.4. Meaning what that means is there are 0.4 gallons in that 1.5 liters of tea. So we know how many gallons we are dealing with in each container, and we know that we have 21 containers that have that much in it. So we need to know how much in all of those 21 containers. So we do the 0.4 times 21. We come up with 8.4 gallons of tea in those 21 containers. On number 2, over a 5-day period, 655 hot lunches were bought at Kingston Junior High. What is the average daily number of hot lunches bought? Well, we want to know how many hot lunches per day, or lunches per day. Well, they told us 655 over a 5-day period. And again, I'm going to I know I've already got it here, but here's using the wrong thing there. There we go. We need to highlight the important information. That's 655 hot lunches in our 5-day period. If I wanted to finish making this a WKU, I'd want to know X over 1 for how many lunches per day. But this is really just 655 divided by 5. So when I divide those two, I get 131 lunches per day. Lunches, I'm going to call this per day. Number 3, find the diameter of a circular garden whose circumference is 80.07. So again, here's my important information. This 80.07, and that I know that it's the diameter, or I'm trying to find the diameter. That what I've got there in red is the circumference. So the circumference is 80.07. When in doubt, draw a picture. I can't draw a very good circle, but there's my picture. I'm trying to find the diameter, the distance all the way across. But what it tells me is that this distance all the way around is 80.07. So what I'm going to do is I'm going to use my formula for circumference. Circumference equals pi times the diameter. We know that diameter already. It's that 80.07. I also know pi. I know that pi is 3.14, and then I'm solving for the diameter. At this point, I just have a two-step equation. In order to get d by itself, I have to divide both sides by that 3.14. The reason I divide both sides by 3.14 is because what I do to one side, I have to do to the other. These two will cancel out, and at this point, I just have 80.07, and I have to divide that by 3.14. When I divide those two, I get 25.4 25.5 for the diameter. And I believe that's centimeters. So our little garden is 25.5 centimeters all the way across. Number 4, Maggie painted a circle on a sidewalk with a radius of 8 feet. So radius of 8 feet. What is the area of the circle that she painted? So again, I'm going to draw a circle. Here is the circle. And it tells us that our radius, or halfway across, is 8 feet. We are trying to find the area, so I'm going to use the formula for area. Area of a circle is area equals pi r squared. We already know the radius, and I already know that pi is 3.14, and we're going to do that times our radius of 8 squared. 8 squared is 8 times 8, which is 64. Now I have to do 3.14 times 64, and I get 200.96, and that's going to be feet squared. Number 5, Debbie has a circular blanket with a radius of 16 yards, very large blanket. If she folds the blanket in half, so we're doing half, to create a semicircle, what is the area of the semicircle she created? So again, I'm going to draw a circle. Here's my circle. We know that this blanket has a radius of 16 feet, so halfway across, and we know that she's going to cut the circle in half. She only wants the area of half of this circle when we're finished. So my formula for area of a circle is A equals pi r squared. And because this is a semicircle, we are going to cut our final answer by 2. So now I'm going to start plugging in what I know. Area, I know 3.14 is pi. I'm going to multiply that. They told me the radius is 16, so 16 squared. And again, I have to divide that by 2 when I'm finished. I'm going to keep going in the same direction. So area, oops, that's a funny looking A. Area equals 3.14 times 16 squared, or 16 times 16 is 256. Still got to divide by 2 at the end. So now I'm going to do that 3.14 times the 256. And on the top part, I have 803.84. And I divided by 2 on the bottom. And finally, I divide by 2. So when I divide those two numbers, the 803.84 by 2, I get 401.92. And I forgot our units, feet. So we're doing feet squared. So again, that is that blue area, or half of that circle, or a semicircle. This is for day 2. The city of Dallas discovered a hole in the middle of the street with a radius of 6 feet. So again, I'm going to highlight important information as I go. Radius of 6 feet. What is the approximate area of the board that will be needed to completely cover this hole? So we're talking about a circle and just area of a circle. So there's my circle. They told me radius of 6 feet. And we're just going to find the area of this thing. So we have area equals pi r squared. We know that pi is 3.14. And we're going to do that times our radius of 6 feet squared. 6 squared is 6 times 6, which is 36. So 3.14 times 36. So 3.14, we're going to do that times 36. We get 113.04. And that's going to be feet squared. Since it says approximately, I would assume 113 or maybe even 114 would be the answer, because I know I need something larger than my hole to cover the hole. So if this was an ABCD answer choice and I had 113 or 114, I would probably go with the 114 because we need something slightly larger than our hole that we started with. On number 7, steel pipe comes in different sizes. A common size to use for irrigation has a 8 centimeter diameter. So again, I'm going to I'm going to highlight the important information. 8 centimeter diameter. A farmer needs to cap off the end of the irrigation pipe. In order to do so, he must find the circumference of the pipe. So we're dealing with circumference. What is the approximate circumference of his centimeter diameter pipe? Okay, so I'm going to draw a circle because I'm not good without a visual. It tells us that diameter, or the distance all the way across, is 8 centimeters. and again that we are going to be finding the circumference. So the formula for circumference that we use is C equals pi times the diameter. Well, we have all the information we need. Pi is going to be 3.14, and our diameter is 8. So we are just going to multiply 3.14 times 8, and we get 25.12 centimeters. And this is not squared because it's just a linear distance. It's not area. Number 8, the figure shows a square inside a rectangle. Write how you would find the area of only the unshaded region. So pretty much what we are going to be trying to find is we're trying to find this area right here. This one's a little more difficult to do because we simply have to describe it. But what I would suggest is I would probably try to find the area of the entire thing. If I knew the area of the entire thing, I would want to take away these portions right here. So if I knew the area of what I just highlighted in red, I would do red minus yellow. You could even do it this way. I'll show it with a wannabe formula. We are going to do red minus yellow gives us blue. If that helps. And just to show you, if I wanted to know the area of just the yellow part, what I would have to do is I would do kind of the opposite. I would take the red section and I would just subtract the blue section. So I would do that red section minus the blue section would give me what's left there in the yellow section. So it's good to know both of those ways of going at this. If you're not sure about this part, make sure you ask me. Maybe I can give you some numbers that might help you out on this part. Taking a look at number 9. What is the area of the figure below? Now, we have two different ways of going at this. Some people may not see that this is a trapezoid, where we can just use the formula base 1 plus base 2 divided by 2 times the height. I could also do the area of the two triangles plus the area of the square there in the middle. Whatever you are more comfortable with, I really have no preference. I'm going to do both for you just to show you. I think it's simpler to use the trapezoid formula. So I'm going to use for my base 1, I'm going to use that top part. For base 2, I'm going to use this bottom part. And then for the height, I'm going to use the 30 centimeters. So now I can just plug in numbers exactly where I've got them. So I'm going to do 15. I'm going to do plus my 21. I have to divide all of that by 2. And then I'm going to multiply by the height of 30 centimeters. When I add the 15 and the 21, I have 36. 2, and I still have to multiply that times the height. 36 divided by 2 is going to be 18. So I have 18 times my 30. And then I do 18 times 30, and I get 540. Again, I think this is the easiest way to go at this one. However, if you needed to, I could do 21 minus 15 and divide it by 2, and that would tell me that this side is 3 and that this side is 3. And I could do base times height divided by 2 for this triangle right here. And then I could do base times the height divided by 2. That would give me this area right here. And then for the square, or rectangle, I could do the base times the height and find this area and add all of those up. I think that's a lot of steps. I think it's a lot of room for mistakes. I would highly recommend using this formula instead. All right, this part is for day 3. The diagram shows the spot on a basketball court called the key. What is the area of the key? Now, this is a combination of figures. Let's start with the easy part. We are going to start with the rectangle here in the center. So to find the area of that rectangle, I'm just going to do the base times the height. So again, I'm going to do the rectangle all in red. So area for the rectangle is base times height. And we are going to do the base of 15 times that height of 7. When I do 15 times 7, I get an area of 105. So my area in here is 105 feet squared. Now I've got to deal with my semicircle right here. So again, the area for a semicircle, or half of a circle, is area equals pi r squared divided by 2. And start plugging in what I know. Area is, now I've got my pi, is 3.14. I need my radius. I need that distance halfway across this circle right here. Well, all the way across is 7 feet. Halfway across is half of 7. So 7 divided by 2 is going to be 3.5. So this is going to be times 3.5 squared. And again, divided by 2. So again, going to keep going through this. We've got 3.14 times that 3.5 squared. So 3.5 times 3.5 is 12.25. Again, we have to divide this by 2. 12.25, I'm sorry, 3.14 times the 12.25 is a big old gross number, but we're going to work with it for now. It's going to be 38.465. And again, I haven't divided by 2 yet. Final step is to divide that by 2. And my area for the semicircle comes out to 19 point gross. I should be rounding on this one. In fact, it doesn't even say what to round it to, so we're just going to stick with this for now. I now have the area of the semicircle and the square, or the rectangle. I keep calling it a square. So I've got to combine these two areas right here. When I combine these two areas, I get a total area of 124 point nasty. It's gross, but there's our final answer. Your answers on the test will definitely not be quite like that. So this one, I would definitely round that to 124.2 would be far more simple. In fact, that's what I think we're going to kind of circle off right here. I would call that 124.2 feet squared because that's much less gross looking. All right, on to number 11. The area shown below is on a street sign. What is the area of the arrow? Let's start by breaking this into simpler shapes. So here's what I'm going to do. I'm going to kind of take care of this rectangle here on its own first because I think the rectangle is going to be a lot more simple to handle. So area of the rectangle is just base times height. So we're going to use the 15 for the base, 5 for the height. So area is going to be 15 times 5. When I do 15 times 5, I get an area of 75. So that is my whole area for this part right here. Now I've got to deal with this triangle right here. First thing I need to do is I need to figure out what this height right here is. So what I'm going to do is I'm going to borrow the 22 centimeters and the 15 centimeters. 22 centimeters is this whole section right here. 15 centimeters is that section right there. If I do 22 minus 15, I know that this height right here is going to be 7 centimeters. So now I have the height of my triangle. Now I need to know the base of my triangle. I need this distance right here. Well, that's 2.5. This part right here is 5, and this part is 2.5. So I'm going to combine the 2.5s, and I'm going to combine the 5. And I know that this whole section right here is going to be 10 centimeters. So a little bit of investigating we had to do there. So now our area for a triangle is base times height divided by 2. Our base is going to be that 10 centimeters, that part I wrote there in green, times the height of 7 centimeters divided by 2. 10 times 7 is going to be 70. And I still have to do 70 divided by 2, which is going to be 35. Now I have my two areas, so I'm going to combine the 35 and I'm going to combine the 75. When I add 35 and 75, I get a total of 110 centimeters squared for the area of that whole street sign. All right, number 12. This one's gross. Jane draws a pattern to help her construct a bow for her sister's doll. How many square centimeters of material does Jane need to construct 3 bows? It is extremely important that you know you're talking about 3 of these bows, meaning whatever our final answer is, the whole thing times 3. So we have to find the area of these shapes here. Let's start with the simple part. We're going to start with the rectangle because that's pretty straightforward. So area of the rectangle is going to be base times height. The base is going to be 3 centimeters times the height of 6. So our area for that rectangle is going to be 18 centimeters squared. So this part right here is 18. Now I've got 2 trapezoids that are the same thing, so this might not be too bad. So I'm going to worry about that trapezoid right there, and I'm going to double that answer so I can have both of them. So area of a trapezoid is base 1 plus base 2 divided by 2 times the height. base 1, I'm going to call base 1 this 6 centimeters here. So I've got 6 centimeters plus my base 2, which I'm going to call this 12 right here. I still have to divide that by 2. And my height, well, the heights are similar. I'm going to use this height right here, which is the same as that height right there. So I'm going to do that times 5. Now to work this out, I've got my 6 plus my 12. So that's my 18. So I have 18 divided by 2 times 5. 18 divided by 2 is 9. I'm going to kind of zoom in and make this a little bit smaller. I know I'm getting really tiny here. So I have 9 times 5, and then 9 times 5 is going to be 45. So again, this part is 45 centimeters squared, and this part is 45 centimeters squared. So I have to add all 3 of these. So 45 plus 45 plus 18. When I add these, I get 108 centimeters squared. Really sorry about that bell. All right, so finally, I have 108 centimeters squared, but I have 3 of those bows. So I have to do 108 times 3. When I multiply this out, I get 324 centimeters squared for all 3 bows. Number 13, look at the algebra tiles below. Which of the following represents a value of x? I would recommend making this an equation instead because I think they're simpler and more straightforward to follow. So I've got x minus 4 on the left side, and I have 1, 2, 3, 4, 5, 6 positives on the right. Simplest way to do this is draw your line down the middle, add 4 on both sides, and you have x equals 10. Guys, if you have any questions on this, make sure you're coming to tutorial so I can help you out.